All right, you guys ready? Class?
Yes.
Look at that. That's actually pretty good. It's better now that all these other people aren't here, right? So, expected value. Expected value is something that goes along with the lottery. Some people in this class are 18 and older, right? Yeah, okay. So, any 18-year-olds here? Good. All right, so, can you buy a lottery ticket? Yeah, you can, right? Okay. So, when you play the lottery, why do you play the lottery? Win money, right? Okay, good. It's a chance to win money. A chance. Anyone actually buy lottery tickets already? That was actually what I did when I turned 18. I went and bought like $20 worth of lottery tickets. The little scratcher ones. No.
You didn't want anything?
No. Okay. But I could. I could play lottery, so why not? Now, the whole point about this is expected value is your cost to reward ratio. So, if you play the lottery, you know what the chances are winning the lottery? It's like 1 in 10 million. Can you believe that? It's like 1 in 10 million. No, it's a number combination. So I can actually do the math for you because there's 42 numbers and one Powerball. So I can do the math for you on that, but it's huge. That's the chances of you winning. But if you win, how much do you win? Millions, right? You win a lot. How much does it cost normally to get a lottery ticket? No, lottery ticket, like $1. They're normally $1. There's a reason why it's $1. Okay, in the past week, how many dollars, single dollars, have you wasted on nonsense? Quite a bit, right? Okay, $1 really isn't much, right? So throwing away $1 for a chance to win, that sounds pretty good, doesn't it? That's the point behind it. But what if they raised it and say, all right, it's now $20 for one ticket. That is, okay, I'm just asking, what if? So you would play if it's $1, right? Because there's a chance and you're not worried about actually losing that $1. But if it's $20 now, would you want to play? No, really, right? Because kind of like when I turned 18, I threw away $20 just because I could. Because I could do it, I didn't win, but I was willing to play, and I didn't win. They actually tried out trying to raise the lottery to the different prices and stuff like that. So $1 is where it's at. If it goes up to $2, $3, $4, $5, people don't play as much. That's what the expected value is for. You don't have a problem losing $1. But if it's $3, $4, nope. $5, nope. Yes, because those are going to be a lot more, but $1. So the expected value is how much you earn if you win versus how much you lose if you don't. We're going to go over that, and that's what this is today. So, page, what do we say, what page we are in the notebook? 33. So let me do number 33. Expected value is a mathematical way to use probability to determine what to expect in various situations over the long run. Okay, they're used to determine premiums on insurance policies. Anyone actually have a car? Do you have to pay car insurance? Your parents pay for you. Wow, must be nice. Wish my parents would pay for me. They never paid for anything. They hated me. Anyway, I had to buy my own vehicle and pay for my own insurance. Anyway, but I'm better off now for it. Okay, anyway, but still. If you had to pay your insurance premiums, there's a mathematical equation to go with that. Weight, risk versus benefit in alternatives and business ventures indicate to a player of any game a chance that will happen if a game is played repeatedly. Standard way to compute the expected values to multiply each possible outcome by its probability, then add these products. Basic. Find the expected value for the outcome of a roll of a fair dice. Okay, if we refer to as a fair die, how many sides does a fair die have? S. Did you guys realize that this is actually not on your notes? Good. Cross out example 2, please. There is a second slide for example 2. Don't cross that one out. And what you're going to do is you're going to fill this in for example 1. So you're going to have to write in example 1 because there was a, I don't know, like a wardrobe malfunction that example 2 showed up, not example 1. And so we're going to cross out 2 because I don't even like that question. It's a bad question. It's almost like, staring at your phone instead of writing down the problem like I asked is, yes, you, DiGiorno.
I was looking at the school message thing.
You're looking at what?
School message thing.
Oh, yeah. Yeah.
I'm not right now.
I know, I just got it too. Okay. At least there's no one I know. No, that's actually going to be a set here in a moment, but I'm asking you to write down the problem. So, since we're all writing down the problem right here, solution, I'm going to have the set, I label it S. On a dice, or a die, what number's going to get on a die? 1. Anything else?
6.
There we go. So that is going to be my set that I'm going to have. Those are the only things I can get if I roll a singular die. Okay? I know your earbuds aren't in right now because I know you're paying attention because ain't no way in... You better put those stupid things away. Yeah, I could see you. Don't even play. Uh-huh. Why do you have like the entire power thing up on your desk? You're like charging your phone, your AirPods, your chair pods, your L pods, whatever they are. Are you really still messaging people right now? Put the damn thing away. Uh-huh, yeah, that's what I thought. Anyway, so from here, what is the chance of getting a 1?
1 out of 6.
1 out of 6. So I'm going to write this down. So to get a 1, it'd be 1 out of 6. And I'm going to categorize these because this 1/2 is my, dang it. I hate it that it does that. It's weird. So whenever I change pens, it always does that. This is my probability. Oh, why did I put 2? We said 1 out of 6, and I still wrote 1 out of 2. I apologize. I'm kind of stupid today. They made me teach an English class, and now I still haven't gone over it.
English class.
Yeah, I had to sub an English class.
Isn't that funny?
Why?
Because you're dyslexic.
Yes, that's horrible. And so all we did is, talk crap about, the best place for waffles. And if you don't say Lolo's, then, you never had a good waffle. If you said, like, Lolo's Chicken and Waffles, like, they make homemade waffle, like, their batter's homemade, which is amazing. Their butter, oh, man, that syrup that they put on that, woo, man. Yeah, if you try and tell me IHOP, get the heck out of here. IHOP is for those people that only had $10 left over and is hungry. That's about it. Anyway, so 1/6 is my probability, and I'm going to multiply this by the value or the weight. 1. So to get a 1, that is going to be referred to as the weight. That is the weight. It is the income or what I get if I get that. So if I get a 1/6 chance to get a 1. And I'm going to keep going for all these. Now, plus, my next weight is going to be 2. What's the chances of getting a 2? 1 out of 6, right? Because there's only 1 2, isn't there? It's only 1 2, so it's going to be 1 out of 6 plus. What's the next one? 3 times the probability. What's the probability of getting a 3? You see a pattern going on here? Okay, the next one's 4 times 1 out of 6, because there's only 1 4. Now, I'm going to do mental math here because it's a lot easier than actually doing it in the calculator. So I know you guys are all paying attention right now and not just trying to put it in the calculator. So 1 times 1/6 is 1/6. Plus 2 times 1/6. Yeah, 2/6. 3 times 1/6. Yeah. 4 times 1/6. 5 times 1/6. Yep. And 6 times 1/6. Now, let's add those together. Let me see. 7, 7, and 7. So it's 21 over 6. Right? 21 over 6. And now divide that for me, please. 7 over 2, which gives me, yeah, it's going to give me 3.5. So your expected value is 3.5. So whenever you roll one of these dice, the expected value should be 3.5. So you should get, whenever you're doing that, in the long run, you're going to get 3.5. So that means, are you looking at your little finger and calling out a half? No. Okay. So, if you play this dice over and over and over again and add together the sum of the total, in the long run, we should come up with 3.5 as the average, and that's what we get, and this is a theoretical. It is theoretical. That means that in theory, this is what you should get. But if you observe, which is slightly different, because I don't observe people playing on their phone during my lesson, because ain't no way in hell Stacy would do that. So, right here, over the long run, it should come out to be this. It's not always going to happen, but it could. Now, this one right here, I'm going to end up doing all this work on another page. I'm going to show you how this works out. And this goes back to you people driving. Automobile insurance company has determined the probabilities for various claim amounts to the nearest 2,000 for drivers aged 16 to 21. As shown in the table, calculate the expected value and describe what it means in practical terms. So, probability. This right means that 70% of drivers 16 to 21 had no accidents. So it cost the insurance company $0. Does that make sense or no? Okay, so it cost them $0. The next one here, it's going to be the down here, $0 is my weight. And this right here, the 70% is the probability. So same thing like we just did on that last problem. Are you writing this down? Exactly. Next one is you're going to have 15% of these people got in a car accident and it only cost the insurance company $2,000. Okay, that's what these next numbers are. 8% got in car accidents and it cost $4,000. 5% got in a car accident and it cost $6,000. 1% got in a car accident and it cost $8,000. 1%, another 1% got in a car accident and cost $10,000. So now you multiply the weight times the probability. So the second one here is 2,000 times my probability of 15%, or 0.15. So as we do this, 0 times 70 is 0. 2,000 times 0.15, or 15%, is 300. 4,000 times 8%, which is 320. 6,000 times 5% is 300. 8,000 times 1% is 80. 10,000 times 1% is 100. You add all those together, and this right here is the break-even point. This is the point where you break even. This is the point where you write this down, because you're going to have this word later on. So that we are breaking even on this. And when we talk about an insurance policy, we take this, and this is every 6 months. Every 6 months. So to figure out your monthly payment, you would do 1,100 divided by 6, which is less than 200. It's like 180 something, isn't it?
183.
183? Okay. 183, and this is what you would pay every month. It's not horrible, right? It's not bad, but this is on average. But this is the break-even point. Now, what's the point of an insurance company? Nope. Try again. Anyone? King Julian. Very good. Really close. Make money. Insurance companies are actually, they're in business to make money, right? Okay. And so since they are in business to make money, this is their break even. That means this is the bare minimum for them to break even. Do they need to employ their employees? They need to pay their employees, right? They got to pay for their commercials with talking lizards and you know, the Shack. What's Shack actually? What's his insurance thing? It's like the General or something. Okay, so yeah, they got to pay these famous people money to actually say buy my crap. So, do you think that that you're only going to have to pay that? No. That's the least amount. That's break even, so that means you're going to end up having to pay more than that. So, probably going to be another $100 on top of that. Now, guess what? That's still not too bad. Okay, I will let you know. My son-in-law, at the age of 16, got in a car accident with a brand new BMW. Like, so new, like they were driving out of the dealership parking lot. The dude just bought it.
Wait, was it his fault or the driver's fault? Yeah, that's
And so for the longest time, his insurance was over $600 a month.
Yeah, I don't think.
Kind of like Mr. Scott not paying attention. That's also crazy. Because I know Mr. Scott wouldn't do something like that, right? So, it is crazy. But that's kind of what they got to do. Do you know why? They got to break even. They got to make money off of this too. And that's kind of how it works. So, and since it's mandatory for everyone to actually have insurance, they could charge whatever they want. Now, let's go ahead and let's go to the next page here and let's do the math for this. Wait, hold on. Wrong one. Am I on the wrong one? I'm not on the right one. There it is. Okay. So we got all this. We added it all up. We got this. So this next one that we have, here it is. This and the other one. I think it's this one we have to write it. Expected value gains a chance to find the expected value of a game. Multiply the gain or loss for each possible outcome by its probability. Then add its products. Now, roulette. So we're gonna talk about the roulette real quick here. Now, do you guys remember it was on the last set of notes? In roulette, how do you spell roulette? R-O-U-L-E-T? One L? T-T? Okay. All right. So, E? There's an E also? I'm sorry. Yeah, I suck at this, so thank you. I appreciate it. Now, in roulette, what do we know at roulette?
Russian roulette is
No. Okay, Russian roulette is when you spin a gun. Okay, that's, yeah, but you have to have a revolver to do that. Okay, yeah, don't do that. Ever.
So is roulette just like
It's a game where you spin the wheel, and if you paid attention to the last set of notes, how many spaces are on a roulette wheel?
8?
What? 8? 8 on a thing? You know you could look at your notes from the previous one, right? It doesn't mean look at someone else's notes. You should be looking at your own notes. What the heck? You had the same problem yesterday.
No, I didn't.
Did you bring your notes yesterday?
I wasn't here yesterday. Oh, wait, I was.
This is why we can't have nice things. All right, there is 38. There's 38 spaces or parts in roulette.
Wait, what problem is that though?
It's in the notes from
Last note?
yeah, the last set of notes. There's 38. 18 are red. 18 are black. And we have 2 green.
You okay?
No. Huh?
You get a higher reward if you should do
No. No.
Why is there 2 green?
Because it has to even out the chances.
Why not just do 18, 19 black?
Have you ever seen a roulette wheel?
GTA or something.
Okay, so you have.
Yeah.
So when you go and bet, you could bet on black, you could bet on red, or you could bet on green. What's the probability? Okay, instead of it actually being black and red, it'd be 50-50, right?
Yeah.
So that means that you have even chances of 50-50 winning each time, right?
Oh yeah.
But in any game that you play at the casino, the house always wins. By that, I mean your chances are less than 50-50 no matter what.
Because of the green?
Because of those 2 greens. It's not 50-50 anymore. It's like 45, 45, 5, 10 or something like that. Or, yeah, something crazy. Or like 48, 48, 2. It's less than. So your chances of winning if you play black would be, what's it? So black, so it would be 18 out of 38. Okay? That's your winning chance, would be 18 out of 38. But your chance of losing would be 40 out of 38. Because you bet on black, but the ones against you is 18 and 2. So that chances are always going to be in their favor. Okay? Does that make sense? Yeah, that's why you shouldn't gamble. Okay, if the ball lands on, expected betting $1 on number 20 on the roulette wheel. Ball lands on that number, you're awarded $35 and get to keep the $1 that you play. Okay, so if we win, think about it, win. What is our chance of winning? We picked a number, didn't we? Angel.
20.
We picked the number 20, right? Okay, so how many numbers did we pick? We picked one number out of how many? 38. So that's your chance of winning. 1 out of 38, right? Because, like, seriously, why?
Oh, no. Oh, actually, yeah, wait.
Okay, here, let me make the set for winning. Okay, so in roulette, we have the set, and you can get 0, 0, 0. You can get 1, 2, all the way up to 38. Those are all the things that it could happen. That's a set of all the things that happen. Number 20. How many number 20s are in this set? 1. So you chose number 20. So you get one choice there, right? So that's why it is 1 out of 30. Oh, I'm sorry. It's not 38. It's 36. I apologize. Because it only goes up to there. It could because of the doubles. So, because it starts with 0, 0, 0, and then goes up to 36. Does that make sense or no?
Yeah.
Okay. So, there's only one number 20 in here, right? So, out of my set, there's only one out of the whole 38. And if I win this, what do I get if I win this? If I win, I get $35 and get to keep the $1 we paid. Does that make sense?
Wait, so what's the game where people like bet like $100,000 they double their money? It's the same game.
Bet on, kind of like betting on black.
It's the same thing.
Yeah. Betting on black, you could double. Or, stuff like that. I'm not a gambler, so I really don't know. Anyway, all right, so there we go. Now, if we lose, what happens if we lose? How much do we lose? $1, right? Okay, so we lose $1, right? So negative $1. But what is the chances of losing now? What is, if you pick number 20, how many here are not 20? So it's going to be 37 out of 38, right? Because these are the not. This is everything but 20. Does that make sense? Okay, good. There we go. And now we do the math. So put this in the calculator. So it's 35 times 1 over 38 plus negative 1, because if we lose, we're losing money. So that's a negative value. Negative 1 times negative negative 1 times 37 over 38. I know you guys are all calculating this for me because I appreciate people that do that. Did you get it already? What'd you get? Okay, negative what? Hit Control Enter.
0.0526. So negative
0.26, like that, right?
Yeah.
But this is going to be in money. So if this is money, what does this actually mean in money? We're what?
We lost 52 cents. Where was the chance and how much we would lose?
How much is this in money? We're going to lose, right? Since it's negative.
5 cents.
Okay, so the expected value come on. Expected value. You're expected to lose 0.05 cents, right? This is 5 cents. Why am I not using the 26? Is this money?
Yeah, you got under it.
Yeah, you don't. Yeah, the 2 is not going to make that round up. So you're expected in the long run to lose 5 cents every time you play. Because, I don't know if you ever hear the saying, the house always wins. You might win every once in a while. In the long run, statistically, the house always wins. Does that make sense? That's why. Now, did you guys write down all of this because it's important? I hope so. Ball lands on any of the other 37 slots. You lose the dollar. Okay? So, and describing it, what it means. So, our gain is 35. This is just a nice table for this. You gain $35 if you win, and your chance is 1 out of 38. Ball doesn't land on 20. That means everything else, all numbers that are not 20, that's where I got that. And I lose $1, and I signify that as having a negative.
Right, but it doesn't mean after 38 people what we're going to win, right? It doesn't mean after 38 people what we're going to win.
No. It's not, listen, it's not intended to ever win. Someone might win every once in a while, but you're more likely to lose. If you win, let's say you win the first time, great. Okay? If you keep playing, they'll expect that you're going to end up losing all the money you just won. That's why that works out. Make sense? All right, now, going along with this, someone was asking me in my first hour, because they want to go actually go gamble. They want to go learn how to count cards. So next week on Wednesday, hopefully everyone's here. Hopefully I will have a couple decks of cards, and I'll show you how to count cards. It requires a lot of mental math, though. A lot of mental math. Anyway, all right. So make sure you all like, share, subscribe, hit that notification button, and support my channel.